Welcome to our second edition of DevTalks, episode 2. This time, we're going to talk about building lightning-fast AI apps with Hugging Face and Gradio. I'm very pleased and excited to announce Abubakar, who actually is near us in the Milpitas, Palo Alto area. We've done a lot of events together. We're excited to have him on board to talk about this, about Gradio. A little bit about Abubakar. I'm just going to introduce him right now. He completed his PhD at Stanford in applied machine learning. During his PhD, he actually founded Gradio, which you guys will know, and he's going to talk a little bit more about it, which is an open source Python library that's already used by 1 million users every month. Gradio was acquired by Hugging Face, which is where Abubakar now serves as head of applications. So I'm pleased to talk about that. Before I dive into Hugging Face and Abubakar is going to present, first of all, I just want to know where everyone's from. I'm based in Palo Alto, right here in the Bay Area. So if folks want to chime in where they're from, that'd be awesome. We always like to know. And then while people are doing that, just want to talk briefly about for those who are just joining us with SambaNova. You know, what we do is we produce a chip, an RDU, called an RDU, that provides blazing fast inference that's very efficient and really runs really great open source models. And a bunch of different open source models we run. You can always go into our playground here in our dashboard, and you can see the bunch of different models and I really welcome you to try it out. But why we really love working with Hugging Face is because they also provide their own inference here, and you can actually use SambaNova as an inference provider. So if you go to Hugging Face's models, and actually Abubakar is going to talk a lot about it. This is just a sneak peek here. You see that we can actually choose SambaNova as inference, and you got all our different models. So even without even you going to SambaNova, you can go into Hugging Face and use us as an inference provider there. So without further ado, I'm going to let Abubakar take the stage here and then talk about Gradio and Hugging Face and show some really cool stuff.
Thank you so much, Justin. Thank you for that introduction, and I'm really excited to be here. I'm going to share this window, and hopefully everyone should be able to see this. So just put together a few slides. I'm going to go through a few different things here. Overall, our high-level goal is building AI applications with Gradio and SambaNova. And what I'll talk about is, I have basically 3 broad points I want to cover. First is I want to talk about what Gradio is. As Justin mentioned, it's a framework. It's a framework for building AI applications, machine learning applications. The second of all, I want to talk about what is the role of frameworks in the age of AI-assisted programming. Probably all of us are using, Cursor, Cloud Code, or some sort of LLM to help us code. So what role do high-level frameworks like Gradio have in today's kind of programming paradigm? And then finally, I'll kind of summarize everything with a very practical example and a library that we are just working on called Trackio as well. So hopefully it should be a lot of new things for everyone here. And again, feel free to ask questions, and I'll periodically check the stream, the comments. And if anyone does have questions, I'll try to answer it either during the talk or we'll have time for Q&A at the end. All right. With that, let's get started. All right, so what is Gradio? So I understand not everyone here may have used Gradio already. So if you haven't, Gradio is a Python library for building web-based machine learning apps with great engineering practices baked in. So Gradio is used by 1 million developers every month to build all sorts of web applications. And it has, you can go and it's an open source library. You can go and find it on GitHub. And it's really something that kind of the idea that we had was we wanted to make it very simple to build good web applications entirely in Python, which is a language that, of course, as many of us as ML developers are most comfortable in. So just to give a very concrete example, a very, very simple example, let's say you want to build a UI or an application that takes a machine learning model for generating images. Let's say something like, I don't know, it could be a closed source model like Nano Banana, or it could be an open source model, something like one of the Flux models. And you can define a function called generate images that kind of wraps over that whether it's an API call or running locally, it doesn't matter, just any sort of Python function. You pass that in as a parameter, and then you pass in what kind of input UI you want to create. So in this case, maybe you want your input to be a prompt text box, your output to be a gallery of images. These are all predefined UI components that come with Gradio. So you just create an interface that has that Python function, that input, or it can have more than one input if your function has more than one parameter, and then output. And then you can run this .queue method, and what that does is it creates a queuing system that can handle thousands of users concurrently using your application, which is very important. Let's say you're deploying this machine learning app somewhere, and then you launch it, and that creates this UI for you. And you don't even have to deploy it anywhere. You can add this share equals true parameter. With this single parameter, what it will do is it'll actually create a public link that will let anyone try out your demo. So your compute and everything runs locally, but you have a public link that lets anyone try out the UI. So that's Gradio in a nutshell. For the sake of just kind of making this a little bit more concrete, let's actually kind of write some Gradio code ourselves. So let's build our Gradio application ourselves. This will just be a very simple placeholder kind of thing. But let's say I want to build a Gradio application. Again, the first thing is I need to have a function. And to get started, so let's just come up with a very simple function. All it does is it maybe, let's say it counts the number of letters in a word or something like that. So let's say count letters, okay, and then I pass in a word, and then it returns a word and a letter, see? And then what it does is it just counts the number of letters in that word. And so I can just use the Python function .count and return that. So now let me go ahead and let me test this method, see if it works as expected. Let's say Hugging Face, G. Okay, cool. There's 3 G's in Hugging Face. SambaNova, no G's in SambaNova. Okay, so very simple function, but we can already do something that LLMs can't do. So, so that's good. Now I can create a UI around this. So if I want, I can pass in this function, and then I can pass in an input here. So what are the inputs that correspond to this? Well, maybe I want a text box and another text box. So I'm passing in a list of inputs because my function takes in more than one parameter. And then the output can be a number field. Okay, so something like this. So outputs equals number, tr.number, and then I launch this. If I launch this, again, I get a Gradio UI that allows me to test this very easily. Again, I can try something like, let's say here, Gradio, how many G's? I get 1. Okay, so obviously this is very, very simple, but the same principle applies for all sorts of different machine learning models. If I wanted to change this into a gallery of images, or let's say an output image, I could do something like that as well. And if my function returns an image as a NumPy array or a file path, it'll get rendered over here. So this is although it's a kind of the idea is very simple, it's also very, very flexible and applies to all sorts of machine learning applications. So that's kind of the underlying basis of Gradio. Now, Gradio has been used to build all sorts of complex UIs, everything from Automatic 111, if anyone has used that, to the Uba Booga text web UI, all these very, very complex frameworks. I'm not going to go into how those are built with Gradio because this isn't really a tutorial on Gradio, but I do want to talk about what we just recently launched, which is Gradio 6. So Gradio 6, and I'm going to present this again here. So Gradio 6 is the latest iteration of Gradio that we just very, very recently launched. And we've had 3 goals with Gradio 6. One is to make it faster. Second was to make Gradio sleeker. And the third, and this is really important, I'll touch upon why this is important later on in the talk, but we wanted to make it infinitely customizable. And so with Gradio 6, we did that a little bit. So Gradio itself is built on, the Python side is just written in Python using libraries like FastAPI. The front end of Gradio, the prepackaged components that come with Gradio, are written in Svelte. And we migrated the underlying kind of framework of Gradio to Svelte 5, which has made it substantially faster. So if you're using Gradio apps written in Gradio 6, you'll actually notice that you can actually feel it. It feels a lot faster. And so you're using kind of state-of-the-art front-end, technology in your Gradio applications. And this is kind of an example of what I mean, where good engineering practices are built in. A lot of times people might build their own, web front end, either code it themselves or vibe code it, but you're exposing yourselves to, kind of security issues, various other issues, performance issues that Gradio tries to mitigate. The other thing with Gradio as well is if you use Gradio 6, you'll find that it's much smaller, which is very important if you're installing Gradio or using, installing libraries or applications that are built on top of Gradio. The third thing that I didn't really talk about yet that I do want to talk about is that Gradio, so far I've talked about Gradio as this library for building these UIs from your, you go from a Python function to a UI. But actually, Gradio actually also goes from a Python function to an API or a Python function to an MCP server. And so what do I mean by that? So when you actually launch a Gradio application, so let me go back to what I had launched before. So if you notice, you have this like public link, you have this link here that's running locally, right? And what I'll do actually is if I scroll down a little bit, actually, let me open this up in a new tab here. So hopefully everyone should be able to see this Gradio application. And so what you'll notice is, oops, did that go away? I'm going to reshare that. Sorry, 1 second. Sorry, let me just share that again. Okay, I'm sharing the screen again. Can you all see that? Okay, great. So yeah, when I open a Gradio application, you'll notice at the top, at the bottom of that application, I have this use via API link. And if I click on this, what I get is I actually get instructions on how to use this particular application via API. Now this is really powerful because if I go back to my application and I say share equals true, what happens now is I have this public link. So if I actually, let me share this link with you all. So you all will be able to actually open this up in your own browsers. And this link is running the application that I just built. And so if I open this up and I use it via API, now you can actually programmatically query this, right? You can say, hey, if I have a Python program, I can actually call this, via the client, or if I have a JavaScript program, or if I have a URL here, curl, sorry. So if I want to interact with this application via Bash, I can do all of that. I can even interact with it via MCP. And for that, I have to set MCP server equals true. But that's really powerful because now if I set MCP server equals true, what that does is that same application now. Actually, what I'll need to do is I'll need to add a little bit of metadata here. So I'll have to annotate, for example, the function. And that's just useful because that way the LLM that's going to be interacting with this can actually start have some context of how to use this. But I can do something like this. What's the number of letters per word? No word. Okay. And I can provide more information and things like that. But now what's going to happen is I can actually use this application as an MCP within Cloud Code or within Cursor or any sort of LLM that you're using. Okay, so let's go back to the slides here. So Gradio 6 also includes a bunch of upgrades to the API and to the MCP usage. So on the, let's see if I can put this, okay. Yeah, so on the API side, the Gradio 6 API is much, much faster. So again, if you have this Gradio application running anywhere, what you'll find is if you're using it via APIs, lightning fast, pretty much as fast as can be. And while at the same time, it also provides you very nice metadata, such as, let's say a bunch of people are using the API at the same time, you'll get ETAs of how long it'll take for your job to complete. And if there's any sort of intermediate steps, let's say you have an image generation workflow, you can actually stream like intermediate images very easily. You can stream audio, images, video out of the box. And what's nice, what I just showed as well, is you'll see these automatic kind of live documentation that's generated, right? So if you've ever built an API or supported an API server, one of the things you have to worry about is creating documentation for downstream users, whether those users are human users or LLMs. Well, now you have automatically generated documentation that stays up to date with what you're building. Similarly, we have updates. So these are like the live docs that I was mentioning before. And you can see, like, for example, you have information about what % of requests were successful, things like that. And also one cool thing is that the docs are live. So let's say you interact with your Gradio application. What actually happens is the data that you put in, let's say you've started using a Gradio UI programmatic, via the UI. But then you want to take those UI interactions and get the equivalent programmatic request. Well, you can do that. What happens is your last interaction is automatically used to populate example queries into that application, right? So if I've uploaded a particular image, if I've set the sliders to a particular value, those are exactly what you're going to see in these docs. So these docs are live in that sense. So that's, again, one thing that's new in Gradio 6. Finally, I'll talk about MCP usage. So again, in order to enable MCP usage, you just set MCP server equals true when you launch. And what that does is, so this actually has been the case even in Gradio 5. But what's new in Gradio 6 is you can actually build ChatGPT apps. So this is something that ChatGPT released, OpenAI released a few months ago. But you can actually build LLM. You can actually build custom UIs for your to show up in your LLM. So let's say we take that same function that we had before that counted the number of letters in a word. Well, I can not only just count the number of letters, but I can even return, for example, an image that shows those letters highlighted. Or I can do something maybe more interesting. I can build a little tool here that brightens images, and I can add a button that lets me keep brightening those images, and so on. So this is a new thing in Gradio 6, ChatGPT apps. I have a link here if anyone is interested in building these kinds of applications. The last thing I'll mention in Gradio 6, but I think is very, very important, is because HTML components. So in Gradio, in earlier versions of Gradio, you had this Gradio component called the HTML component, gr.html. And what users used it for was to pretty much show kind of static HTML. Let's say you wanted to display a bunch of like videos or something in a very custom format. You could use Gradio.html to do that. But in Gradio 6, gr.html can do so much more. What it can do is it can be used to create completely custom components that extend Gradio's functionality. So in previously, you had something like if you want to display a list of buttons, you could do that with gr.html. But now what you can do is you can actually create entire templates, right? So you have an HTML template that gets populated based on the value of the component. So the HTML template can be arbitrary. And the value can be arbitrary as well. So the value can be a list, it can be something else. And so the HTML template defines how that value is converted to a front end. It can take props. It can take CSS, scoped CSS, so you can use that to really stylize your HTML component. You can trigger events. You can trigger custom events with gr.html. So every Gradio component has particular events that define how kind of it interacts with other with Python functions that are defined in your code. And with gr.html, you can add custom events. A click event, a double click event, anything that you want. And it can act as an input component as well. So what this essentially means is that you can use gr.html as a way to define reusable components for your Gradio application. And so you can create, so for example, in this case, we have created a completely new component called options. So this is not something that exists in core Gradio, but I can define it by subclassing gr.html. And I can say, okay, this is the value that it should take. These are the choices. These are like the props. These are the attributes. So if you've used Gradio before, you know that every component has certain attributes. And so what this does is this lets you create whatever attributes you want, and then again you define an HTML template that takes those attributes and turns it into kind of a front end for you. The reason this is so powerful, okay, if I was to summarize everything, the reason why everyone should use Gradio 6 as opposed to earlier versions of Gradio is that this breaks the walled garden that Gradio used to be. So in Gradio 5 and earlier, you kind of were limited to the predefined set of components that Gradio shipped with. And you could create custom components, but it was a lot of work. It required knowing Svelte and installing Node and kind of doing the whole build process that we do in Gradio. But in Gradio 6, you can define custom components entirely just by writing some basic HTML and JavaScript. And you can write this, or an LLM can write this for you. And that's really powerful because we have, what we've seen is if you provide, again, Opus or even one of the kind of, pretty much any of the latest LLMs with a few examples of these HTML components that we have in our guide, if you copy paste that, provide that as context, LLMs are great at writing new components for you. And with that, so that kind of wraps up Gradio 6. So again, the reasons to use Gradio 6 is a much faster and lighter version of Gradio. It's also much sleeker. I didn't talk about that too much, but the components and the docs have undergone a major revamp. And then finally, you can break out of this walled garden. You can write super custom components and use them within your overall Gradio application. So with that, I want to touch upon one other thing, which is Our SambaNova integration. So Gradio comes in with this very nice SambaNova integration, and I'll demonstrate that in just a moment. But that is also much faster now. And again, it's much more customizable. So I'll just show a quick example of this. So Justin mentioned this earlier. So let me go back to so if you go to Hugging Face and you go to our models, you can actually filter by models that support inference, right? So we have about, so if I, and I, then I'm going to filter by, let me reset this, by the ones that have SambaNova inference. So let's take a look at some of these. So for example, DeepSeek R1, I can see that the inference is being provided by SambaNova, and because of the custom chips, it's very, very fast. So DeepSeek is, DeepSeek R1, it's a thinking model, it's a reasoning model. If you ask it a question like, what are all of the roots to x cubed equals 1, it'll think about it and then give an answer, So, it'll think in detail, and usually this takes a little while, but because we have this very nice integration with SambaNova's chips, these kind of the responses come immediately. And you can take a look at this. You can see that this is not bad, but maybe I want a nicer UI because again, for example, the LaTeX is not being shown and so on. And so what you can do, which is you can build a Gradio application around these inference APIs. And so to do that, it's actually quite straightforward. All you have to use is this gr.load function. And this gr.load function allows you to pass in any sort of model on Hugging Face. And then you pass in the name of that model. So in this case, I passed in DeepSeek AI, DeepSeek R1, and then you can choose a provider. So in this case, I've set SambaNova because I want that very lightning fast inference, and then I just do launch. And again, you can kind of see this here. A UI has been created automatically. You can customize it. I won't go into the details here, but you have your Gradio application for you. And again, if I want a public link, I can create a public link for it, meaning that, again, any one of you guys can try this out and start interacting with this application. Okay, so with that, I'm going to keep going. I'll just mention that if you want to try using Gradio 6, you can just pip install upgrade Gradio, or UV pip install upgrade Gradio, and we have a migration guide that explains what things have been deprecated from Gradio 5. Now I want to move into the second part of the presentation, which is Gradio and other frameworks in the age of AI-assisted workflows. So one of the questions that we've asked ourselves a lot, and sometimes we get this question from users as well, is, Gradio is fantastic, it's great, it makes things, I can write front ends without knowing JavaScript, HTML, CSS, but so can LLMs, right? So in the age of AI-assisted workflows, should I be using Gradio, or should I be using an LLM to write custom JavaScript, HTML, CSS for me? What should I be doing? And there are several reasons why users still build Gradio applications instead of something that's native, and I'll mention a few of them. So one of the main reasons is, at the end of the day, as machine learning developers, most of us think in Python, right? We think in terms of inputs and outputs. We think arrays, images, text. We don't really usually like to think about DOM events and state management. And so Gradio lets you continue to think in Python. So you can write your AI application, or an LLM can write it for you. But when you come to understand the code, maintain the code, edit the code, it becomes much, much easier to do that in Gradio, where you don't have to worry about going over. If you've seen an AI generated application, usually there's tons of front end files, tons and tons of front end files. And using Gradio lets you keep, oftentimes your entire application can be a single file of Python, which is very nice for maintainability. The second reason, again, of keeping everything in Python is you get to have a monolingual code base. And this is super important. A monolingual code base means you can use unified tooling for testing. Everything can be done in PyTest. So everything from your unit tests to your entire E2E, end-to-end tests, integration tests, everything can be run in Python. Linting, development, everything can be done with UV and rough. While you're developing, you don't need to have a separate front-end server running. Gradio can kind of deal with all of that for you. And while still giving you some of the benefits of having a front-end server, you can have hot reload mode in Gradio and things like that. It also gives you a much, much more reduced area for bugs. So I didn't talk about this a lot, but Gradio includes a lot of very good security practices built in. So you don't have to worry about things like CORS or auth or versioned APIs. All of that comes for free with Gradio. And finally, Gradio apps are much, much more concise than other applications, which just means, okay, less tokens or less code. If you're writing it or an LLM is writing it, you generally have much fewer tokens or much fewer lines of code that are involved. This is not hypothetical. I actually mean this very practically. And so kind of the last part of the talk that I want to talk about is an application that we built on top of Gradio. And we've built it, with ourselves, but also using LLMs, state-of-the-art LLMs. And I want to talk about how we built it and why we decided to build it on top of Gradio. So first of all, what is this library? So this is a library called Trackio. And Trackio is a free library for experiment tracking, right? So let's say you're training your own machine learning models, you want to log metrics. There are some other libraries out there, like Weights and Biases, Comet ML, Neptune, but now it's acquired and shutting down their experiment tracking software. Now the thing is, with all of these libraries, pretty much all of them are cloud first. So in other words, you can log your metrics, but you need to create an account. And at any moment, you can't be doing it offline. And at any moment, if that company shuts down, or let's say Neptune gets acquired and decides to shut down their experiment tracking software, all of your logs are pretty much trapped inside this kind of, behind this cloud system. And so with Trackio, everything is local first, and it's super lightweight, and it lets you track your experiment tracking kind of metrics very easily. And it has the same exact API as Weights and Biases. So if anyone uses Weights and Biases, you'll find the code is pretty much identical. And what's amazing about it is because we've been able to build it on top of Gradio, pretty much all of the code is written in Python. So including the UI, so the dashboard that displays these experiment tracking, kind of these graphs and so on, all of it is written in Python. And so what that means is if you look at the code for Gradio, if you look at the code for Trackio rather, it's something that's quite readable, right? As Python is very readable for us as like Python developers. Everything is like in terms of if statements and for loops and kind of these with context that are very recognizable, and all of the parameters that you pass in, all of that, a lot of that front end code is abstracted away. You don't have to worry about how these line plots are defined because it's just using the line plot element in Gradio. Furthermore, like I was mentioning earlier, all of the tooling is in Python, which is great because the Python tooling, you don't have to have like a separate kind of tooling or tests for the back end in Python and then the front end using vtest or something else. You can actually do it entirely using PyTests. So we have 4 different kinds of tests in Trackio. We have unit tests, we have UI tests, we have end-to-end local tests, and then we have end-to-end tests on spaces, on Hugging Face spaces, which is lets us kind of deploy this into the cloud. And you can also deploy your Trackio kind of dashboards to the cloud as well. And so you can do all of this entirely, again, because Trackio is entirely written on top of Gradio, we can do all of this testing and development within Python, which I think can be really powerful. Okay. At the same time, one of the reasons sometimes people reach towards LLMs instead of framework is, well, what if I want to actually customize something and your framework doesn't support it? And again, one of the powerful things is this super HTML component that I mentioned here. So sometimes we do want to create UI kind of components that are not supported in Gradio. Well, that's fine. I can define my own component. And the nice thing is that I have 280 lines or so of like HTML JavaScript that is isolated in that file, right? Like I can keep the JavaScript and the front end, the CSS code in one file, and I can have an LLM write it for me, and I don't have to think too much about it. While the core logic of my overall application, of my Trackio application, is written in Python, and it's something that I can understand, I can interact with, I can kind of change that as much as I want. And what that ends up creating is a very lightweight and very forkable repo. So if I go to Trackio right now, it's a pretty lightweight. If I go to Trackio at the moment, it's a pretty lightweight repo actually. Let me see here. So I think it's about 5,000 lines of Python code, right? Super lightweight. And that includes everything. That includes the front end. That includes the logging logic. That includes deployment logic if you choose to deploy it. At the same time, it's super forkable because it's written entirely in Python, which is a language that LLMs know well, And because it's also designed in a very modular way, if you want to change the front end of Trackio, if you want to keep like the logging logic, the logging, the infrastructure, and so on, but you want to have your own custom UI, that's completely possible, and that's really important now in an age where writing software is so cheap. What is the kind of the value of open source? Well, the value of open source is still being able to take a project that mostly exists, mostly suits your kind of workflow, and rather than recreating from scratch, you just fork it, you customize it. And again, Trackio lets us, Gradio and Trackio lets us do that because we have a concise Gradio application. There's fewer LLMs token involved, right? So for an LLM to then go through the Gradio code, the Trackio code base requires much fewer tokens. For it to make modifications, changes, requires much fewer LLM tokens. And then because we have this Python-based toolings that LLMs know really well, they can use that tooling to verify implementation to make sure the changes that they make sense. And it's very modular. You can use the lagging features independently of the front end. In fact, one of the things that we've even done with Trackio is we made it LLM friendly. So you can log the data and then not use the front end at all. You can use a CLI for programmatically accessing the data and for managing the runs, which makes it really easy for an autonomous LLM to log metrics and then query the experiment data. And of course, I should mention that Trackio is completely free to use as well. So that is kind of a summary of the main things that I wanted to talk about. Gradio, the integration with SambaNova, and finally Trackio, which is a project built on top of Gradio. With that, that wraps up the talk that I had. I'm happy to take any sort of questions from users that are, if you have any questions based on any of the stuff that I've talked about, or if you know things about Gradio and you have questions there, happy to talk about that as well. Let me go back to the chat here.
Great. That was a great presentation, by the way, Abubakar. I'm one thing I love about Gradio is the ability to use Python to be natively, right? I mean, I think you're absolutely right. Like HTML, I mean, especially working with DOM events, calls, it can be very complicated. But Gradio, I mean, in a way, is the right word, like abstracts away from that, and you can write your applications in Python, which I'm the most familiar with. And I hope I'm summarizing that correctly here. I know James has a question here, like, what are your favorite ways to use MCP servers? And I think I have a similar question here. Like, what are your favorite, like, all-time Gradio apps? Like, and I hopefully James is similar. Like, and I want to know, like, from like the crazy ones to the useful ones, right? Like,
yeah. What? So they're great questions. So what I'll do here is we've actually had in the past few months, we've actually had MCP hackathons at Hugging Face.
So we've been a part of, SambaNova has been a part of 2 of them, and it's a crazy amount of people joining and building it.
Yeah, exactly. And so what all of those applications, we end up publishing them on Hugging Face Spaces, or the developers end up releasing them on Hugging Face Spaces. So what you can do is you can go to Hugging Face Spaces, which is like this general AI app directory, and you can filter by those spaces that are MCP compatible. And so we end up with is still, I would say, I think it's more than, several thousand, actually, let's see, 24, I think more than like 5,000 different MCP spaces here. So so in terms of what are my favorite applications to use, MCP servers to use, I would say those that add some sort of, so I have different use cases where I use LLMs, right? So for example, one of the ways that I've been exploring using LLMs recently is to put together podcasts, okay? So when you have something like this, so you want LLMs that the problem though is that LLMs don't natively have the ability to generate speech, right? No. So but no problem. I can actually find MCP servers that I can add to my LLM that do support that. So for example, I filtered by MCP compatible. I can say, okay, I want some speech generation ones, so speech synthesis. And so you can see here a bunch of different MCP servers here that do exactly that. One of my favorites.
And Abubakar, I want to pause you. Is that on your screen right now? You have it? We'll just share your screen quickly if that's fine with you.
I'm sorry.
No worries. We'll just share your screen quickly right now, and then if that's okay with you, and you can show us. Wow, this is amazing. Like I particularly love Hugging Face because of its open source nature, its community, and where you can see everything. So sorry to interrupt you there.
Yes, let me just, no, thank you for that. Let me just walk through that again because everyone may not have seen that. So exactly, as Justin, as you said, the community has built these, at this point, millions of spaces here. And so these spaces are all like, individual Gradio app. Most of them are Gradio apps. There's some other frameworks as well. but you can filter by those apps that are MCP compatible.
Mm.
So all of these are, most of them, yeah, they're all Gradio apps that support this. You know how I mentioned this MCP server equals true.
Yep.
And so I'm going to filter by speech synthesis here. And so one
Oh,
of my favorite Gradio apps, one of my favorite like MCP servers is Chatterbox. So Chatterbox,
Chatterbox. Okay.
yeah, Chatterbox is a fantastic, it's a very, very high quality a TTS, so speech synthesis, text to speech type application. And so you can use it to generate kind of, any, you can, give it sort of any sort of text and it'll convert it to speech. And so you can do that here, and we'll see it kind of produced here. And but one of the amazing things is that it supports voice cloning. So you can put
Oh,
in
wow.
a reference audio. So let's see here. So this was the reference audio. I don't know if everyone will be able to hear
I
this
don't
or not.
think we can hear it, but
Can you hear that or no?
no, unfortunately, I
Okay,
can't. But
that's fine. I'll share the
definitely.
link. Yeah,
Okay.
I'll share the link so people can try this themselves.
Thank you.
So this is again, I'll just mention that this is a few interesting things are going on here. So first of
Mm.
all, this was built by the community, just to emphasize that point, Justin. Resemble AI, which is a startup, I believe, that built Chatterbox, built this application. And what they did was they built the UI, and then it's an MCP server. So you can again use this via MCP. So just add this as a and MCP server to your, again, it could be Cursor, it could be Cloud Code, whatever it may be, and then your LLM will be able to generate speech, right? So now the thing that's interesting is that
Mm.
you actually MCP servers are interesting by themselves, but if you start combining them, you start getting really interesting things that can happen. So, for example, let me show you another very cool MCP server that's also a Gradio application. This one called Maya One. And so Maya One lets you generate a voice based on a description. So you can say something like this: realistic male voice in the 20s, age with an American accent, yada yada. Or I could do something very different, creative, like a robotic voice, or kind of a singer's voice or a female voice, whatever I want. And it actually generates a voice sample with that voice. Now imagine taking that voice then and passing that as a reference to Chatterbox, which is a very high quality
Mm.
model, and then generating any sort of text that you want. Again, this could be useful. So one of the things that, because we've recognized that all of these community members are building amazing MCP servers that are cool individually, but can be even more powerful in combination. One of the things that we very recently released is this library called Toolsets, and I'll mention it just because of this question. And what Toolsets lets you do is it lets you combine MCP servers into, like, imagine you find like 8 or 9 MCP servers you really like on Spaces. Instead of having to individually add all of them, you can use a tool set that combines all of them into
Wow.
a single MCP server. And now you can add just this kind of one MCP server to your LLM. And now I created one kind of for that, for podcasting. So I have an MCP server I have one MCP server that has tools for transcribing audio,
Wow.
for generating voice samples, and then again converting that using Chatterbox to generate TTS, generating music as well, right? Maybe you want some intro music for your podcast. Now your LLM can do all of that for you, and then combine it, in smart ways to create a full podcast. And then there's other nice things like you don't have to load all of the tools at the beginning, which helps you save your context window and things like that, which again can be, and Toolsets takes care of all of that for you, so you don't have to think about that.
I just want to say, I'm trying to interrupt you. I love this design. And the reason why is like when we're programming, we want to make reusable components that
Exactly.
are functional and basically simplify each component so it's easier to debug. And I love this even more so because here's what I get from each of these tools. You could use a different model. Or, I don't know, like each of these tools can use a different model. So like, I'm just have a plug for SambaNova, but any inference provider. Some
Mhm.
models are more expensive than others. And
Yeah.
so you might want to use a smaller model for certain things that don't require as much, for example, reasoning or something like that.
Yeah.
Am I right in the way I'm
Exactly.
thinking about it?
Exactly. So you don't have to use, that's a very good point. You don't have to use your core LLM for things that don't require that. So for example, your core LLM could be, let's say using Opus, but you
Yeah.
don't, Opus 4.5, but it's obviously a very expensive LLM to use. And so you can delegate tasks, right? You can have a specific MCP server that's built on an open source model, with SambaNova, lightning fast, super, super fast.
Yeah.
When Opus delegates it to that, let's say it's for something like I don't know, let's say summarizing text.
Summarization, yeah.
Yeah,
Mhm.
which is something that LLMs can do really well.
Yeah.
Even LLMs from 2 years ago could do pretty well.
Yeah.
But open source state of the art LLMs can do very, very well. You could create an MCP server. You could create a tool around this, add it to your tool set if you wanted, and that way you have Opus can be smart about delegating that and then using kind of these other tools where it makes sense.
These
So
two, no,
tools.
the two set. I think to me that's an amazing paradigm shift on how we think about MCP servers, about tools, using that, really breaking it down to specific tiers that we can chain together. So
Yeah.
for the podcast tool, that I have a question. For the podcast tool that you built, is there one person speaking, or do you have two people?
Yeah, you can do it either way because for example, using Maya, I can generate multiple voices. So again, so the way the workflow could be, you tell your LLM, I want a script with a host and with a guest, and then it generates that script for you. And then let me stop sharing here, that way we don't see this double screen.
Okay. We can stop sharing your screen.
Okay.
Yeah,
Perfect.
great.
Awesome. So basically, we have this, like you were saying, so you can generate a script with an LLM, a host, and a guest speaking. And then what you have is, you can then say, using Maya, I want to generate voices for each of them. And again, because it's in this modular way, I can if I don't like the voices, I can rerun that bit. It's not like it's generating the whole podcast and all of this stuff. You can generate the voices. Once you're happy, you've iterated on that. You can say, okay, use this for the host voice, use this for the guest voice, generate a complete podcast. Okay, it looks great. I can add intro music, again, using Music Gen or one of the other many different open source models out there. So I do think, like you said, I think in the near future, it's going to be very normal to have an LLM with hundreds of tools. And tool sets is something that makes that a little bit easier. So.
Wow. And so a question I want to ask is, you see a lot of Gradio applications being built. One or two or three best practices that you've seen that are like people, you recommend people when they're thinking about Gradio applications?
Yeah, definitely. Maybe again, maybe I'll share my screen again. Sorry for that.
No problem.
But that way,
I love it. And again, just for the audience, these are just impromptu questions. Feel free to ask questions away too.
Let me share a space that I think is very well built for different reasons. But so this is Microsoft. Microsoft released a space called Trellis.
Amazing.
So Trellis came out I think maybe a couple of years ago. Trellis 2 just came out. It's a very, very cool model. What it does is it takes in any image. So you pass in an image, and it generates a 3D kind of object from that image. Right? So yeah, so pretty much you can see here, this is just an image of a crown. There's no...
It converts a 2D image into a 3D object. Wow.
Exactly.
Okay.
That you can take that and you can use that inside a video game, or you can even 3D print it if you wanted. It's a complete kind of 3D object. So one of the things that you'll notice about this is, so they built a Gradio app. So when a lot of labs will release new models, they'll actually release Gradio apps for it. So you can see here, not bad, I would say.
Yeah.
You can edit this as well. Let's get the original. No, 3. Yeah. So right. So this app though does a lot of good practices that I kind of like. So I'll kind of just mention this. One of the things that it does is, okay, so they've released it on Hugging Face Spaces. So obviously, this is just to start things. When you build a Gradio app, Spaces is a very nice place to publish it because of two reasons. One is it's free, and instead of keeping it locally hosted, now you can share it with the world.
Yeah,
a huge community of people, 800 different people liked it. Who knows how many people used it? But the other reason it's really powerful is because it's running. You can use 0 GPUs. So zero GPU is a special hardware that we've built at Hugging Face that lets people basically share GPUs. So it lets the community use your 0 GPU application for free, right? So nobody has to worry about paying. There is some cost associated with it, but we cover it. So essentially, the community can try your application for free. And so you just have to it's just add a decorator to your code. It's like literally a one-line code change in order to make it compatible with 0 GPU. So anyways, so they've released their Gradio application on Spaces, which is important. They've made it 0 GPU compatible. They've also done some other nice things. They've provided a bunch of examples. That always makes it much easier rather than for me to have to dig around my computer and find examples to pass into this Gradio application. it just takes care of that for me automatically. So that's useful. The other thing that they've done, which I think is great, is they've had this multi-step process. So a lot of times Gradio applications will be way too noisy. People will be trying to fit multiple steps all into one UI. Instead, you can use the walkthrough component. So they've used the walkthrough component here to first let people preview it, and then finally, once they're happy with it, then they can extract that and then actually convert that into a GLB file. Oh, in this case, it errored out.
And this is a component, the walkthrough component is a component added, provided by Gradio here.
Exactly, it is, yeah. So Gradio has this walkthrough component that's designed for this exact use case. It has multiple steps. You can create this step-by-step workflow.
So that someone can learn immediately how to use your Gradio application.
Exactly, it's kind of like that. It walks you through it. Yeah, exactly. Yeah.
I love that. I just want to I didn't know about the zero GPUs capability, but I want to let people know that this is something I'm definitely going to use, because as we know, the curse is the more popular your application becomes, the more costly it's going to become. So then here,
you don't have to worry about the inference cost. You just release it on a Hugging Face Spaces, and again, people can use it, via the UI. People can start using it programmatically, at least for some kind of experimentation. People can use it within their LLM. So all of that is kind of, you don't have to worry about the inference costs associated with that.
That's huge on there. And what I noticed about the Microsoft application was that the way to get from something usable quickly was really fast too.
Yes, exactly. You have this machine learning model, but of course, if you want to build something that's actually usable, something that the community will interact with, it's going to be it's going to be a lot easier with a Gradio application. And I'll mention actually one kind of other thing. So Microsoft also released this model just today, just actually half an hour ago, I think.
Great. Did you want to share your screen again?
Yeah, I'll share my screen again. Yeah. So it's called so the repo I'm sharing is called Vibe Voice. So Vibe Voice came out. So Vibe Voice is a whole set of models. Actually, it's a collection of models. But what just came out recently is Vibe Voice ASR. I think it's, let me see, 48 minutes ago or so, or at least today. Yeah. So basically, it's a text-to-speech model that can handle very long audio, so 60-minute long form audio in a single pass, and generates structured transcription, including who the speaker is, when they spoke, what content they spoke, and things like that. So it's a very, very cool model, very nice model. And one of the things that we see is that, when the model was released, one of the first things that they did was they, where's the ASR model? One of the things that they did, here we go. So the demo here, where's ASR? Yeah, so the Vibe Voice ASR Gradio demo. So within the repo, they included a Gradio application, again, making it much easier for people to actually use it because, again, it's just, if you're releasing a machine learning model, you want to make it as usable as possible, because nowadays there are so many models being released. It's not just about how good your model is, but you want to make it as easy, day zero, come out with a Gradio application, let people use it locally and on Spaces, I would say.
No, I totally understand that, because if I've got a model and I want to get an application up, the previous way to do it was, I need to build a HTML page, I need to host it somewhere, I need to build an application. My HTML coding is terrible, by the way. And now with a Gradio, and then if I want to use it as an MCP server, I've got to build an extra thing on top of that.
Exactly.
But now with Gradio, I'm like, Python, UI, I've got a community of people to use it, and now people can test it, and everything comes for free with that case.
Exactly. That's exactly what we want. People to take their Python functions, and basically we want to let people have these superpowers that they wouldn't normally have just based on defining a function. Once you have a function, you can expose it as a UI, as an API, as an MCP server, very, very easily. So
you get all this stuff for free, including if you're using GPUs now.
Yeah,
exactly. You can get that for free, which I think is huge. Yeah. I would highly encourage the community to do it. I'm just gonna make a call out for any other last questions before we wrap up. I'm gonna share. Let me just share my screen quickly here on Hugging Face. Really quickly, we love partnering with Hugging Face. You guys use inference a lot, and I talked about this. Abubakar talked a lot about it. I think the power behind using Hugging Face's inference, and I just want to let you know, is that we're using Hugging Face's inference. You can always use SambaNova as an inference provider. But the power is that, you get just through one API call. I'm going to find the call down here. You get to choose like what I talked about, the models and then the inference provider. So you can switch between different models. Of course, I encourage you to use SambaNova inference model, the models that we provide. But you can, like super fast. I mean, that's how we provide ourselves here. Like if you go through it, feel free to test it out. You see us that we're really fast. Like what can I build with Gradio? Maybe something just like that here. And then, you see that immediately it just comes out. Or it's starting the reasoning. But what's really powerful again with Hugging Face inference is that you get to choose different providers and models really quickly. And that's what I like about it. And I think I really see a future where like with Gradio apps, again, you have different tools, you have different models, specialized models for each particular task, and then adding them up together really provides powerful applications. I for one am super stoked. You already talked about Gradio 6. What do you, sorry, I'm just throwing a curveball here. For Gradio 7, 8, 9, 10, what is your vision here? Like what do you think, or what would you like from the community to hear about, to give feedback on here?
Yeah, absolutely. Well, I mean, we're actually just like road mapping that, and we'll see where things go. I mean, we're very excited about the kind of applications that the community wants to build. One of the things I've heard from folks is robotics. They want to see they want to be able to have these very interesting like these desktop robots. We would love to be able to program them, build applications, share them. Who knows? Maybe we'll go in that direction. But generally speaking, I would one of the things we think a lot about is what are the hard parts about building AI applications now, right? One of the hard parts that really used to be very, very hard is a little bit easier now is like front end development. But what's still hard? So hard, managing hardware, like we're talking about zero GPU, that's still a little bit hard. So we're trying to figure out what these kind of blockers are to building AI applications openly and sharing them with the community. And we would love to kind of solve that for the community. So if you have suggestions, open up issues in our GitHub repo, and we'll kind of follow the direction that the community sets. So
I love that. And I'm just going to end it off. The call to action, I guess, from the community, Abubakar, is really, hey, use Gradio, SambaNova's inference, but really find out like what are the difficult parts or what's stopping you from building these applications, and then pass it on to Abubakar and his team, and then they will, you're going to make it easier. You're going to simplify it.
Exactly.
Yeah. Great. Well, with that, I'm going to end it. Again, thank you, everyone. And again, I also the call out on the robotics was amazing. Thank you again for attending, everybody. We do this monthly. We invite Hugging Face over to our events a lot. We love working with them. And thank you, everyone, for attending.